Dickens, and I'm a security consultant here at Encryption Consulting. And today we'll be diving into the topic of securing the software supply chain, specifically with code signing. Now, just to go over a few of the topics we'll touch on, we will touch on the importance of securing the software supply chain, as well as an idea of what the software supply chain is and how it works. And then we'll touch on code signing, how code signing works, why you should use code signing in your software supply chain, some common challenges and threats and risks that you may face with code signing. And then we'll also touch on a few of the more recent code signing attacks that have happened over the years, specifically the Kaseya VSA attack. And finally, we will touch on the best practices for securing your software supply chain. So let's get started. So what is the software supply chain? The best description of it is really any interaction by a developer or anyone within the software development lifecycle where they specifically handle the software in question. So the software development lifecycle, just to give you a little bit of background, is this wheel I have in the middle here. And it's basically a cycle of planning your code, analyzing it, designing that code, actually implementing the code, any testing and integration that goes into the design of that code, and then that final maintenance of the code itself. And the reason I bring up the software development lifecycle is because it does go hand in hand with the software supply chain. And this entire process is so crucial in the development of software. And the reason I say that is because if at any time there is a developer or someone who manages to get a hold of that code during any part of the software development lifecycle, whether that be phase 1 of planning or phase 6 of maintenance, and they were to introduce malicious code in some way, then that would compromise the entire software supply chain, as well as compromising any customers or users who may use this software in the future. So getting into this a little bit more, we have these different portions of the software development lifecycle, and it's extremely important to protect your code at every instance. And that doesn't mean you're going to use the exact same method of protecting that code, but certain things like code signing platforms are a great way of covering your software supply chain all across the board at all times, so that you don't have to have any worry of malicious code getting introduced into your software, your firmware updates, anything like that. Now, moving on into a little bit more on the importance of the software supply chain. Like I mentioned, every step of this software supply chain is vital to the creation and that design of that software. And so every step needs to be protected. And the reason I bring up, protecting at every point in the chain is because malware could be introduced in a phase as simple as the design phase. And if it occurs there and it's not being checked throughout the supply chain, then catastrophic issues could occur where, a threat actor could introduce malware to every single user or end user of that product, including the developers of the code. Or even worse, you're putting out software in your organization's name, and you're likely a trusted name in your industry. Well, by introducing software that has malware within that software, you're ruining your own reputation and hurting users by infecting them with malware, and B, hurting your own reputation, where they may see your name in the future and say, oh, last time I used their software, downloaded code from them, it infected my computer, and I lost a lot of different things, and now we don't trust your organization. So it's just extremely vital to be protecting your software supply chain so that you never put out software that is infecting users, is in any part of the process doing anything malicious to an end user's computer, things like that. So now that we've kind of touched on the supply chain itself, let's get into our recommended way of handling protection of the software supply chain. And in this case, it's code signing. Now, code signing, if you've never heard of it before or you only know minimal about it, is a way of authenticating the identity of a developer to a user. And they're not only putting their name on the code and putting their name on the line by giving out that code, they're also ensuring that there's no There's been no malicious alteration or compromise of the software in question in transit or at any other part of the software supply chain. So to get into a higher level look at code signing, the way this begins is a software publisher, decides that they would like to digitally sign their code. So the first step is generating a private and public key pair and creating a certificate signing request, or a CSR. Now, with that key pair, you always want to keep the private key private, but the public key can be seen by anyone. And the reason for that is this third step in the process, which is submitting that public key and that CSR to a certificate authority. Now, using that public key, the certificate authority can identify that the identity of the publisher attempting to get the certificate is valid, and they can also authenticate that publisher's digitally signed certificate request, the CSR. And the reason for this is it adds a number of different checks and balances within your process so that someone pretending to be the organization can't just go to any certificate authority and ask for a code signing certificate. You'll see in some of the attacks we discuss that, stealing a private key from an organization is really the only way you would be able to identify yourself as an organization when you're really not that organization. So now that all the verification and authentication has gone through, the certificate authority will bundle the identity of the publisher with the public key and sign that bundle with a digital signature from the issuing certificate authority, which creates that code signing certificate. Now the certificate authority will issue that digital certificate over to the software publisher, and they can begin to sign code. Now, the importance of this is you will usually have, especially on code going out externally outside of your organization, you'll usually use a publicly trusted certificate authority, and those can be identified from any computer as long as it's a publicly trusted certificate authority and not one that is internal to your organization alone. So they'll know that the code was signed by someone they can trust and that they also trust the publisher of that code. So that's just one of the many reasons we suggest code signing for securing your software supply chain. Now, going a little deeper on the actual code signing process itself, like I mentioned, we have this creation of a public and private key pair and that CSR. And then passing that over to the certificate authority, you get your code signing certificate back. Now, the actual code signing process is a little more involved in this case. And the importance of this all circulates around hashing your code. And the way hashing code works is you'll pass your code into a hashing algorithm. And that hashing algorithm will create a fixed length digest of the file. And the reason that it's fixed length is because the way the hash works, or the hash digest as it's called, is it is a cryptographically unique representation of the file. So what I mean by that is when you pass a file, a code into a hashing algorithm, it will create one hash that cannot be recreated unless you're using the exact same hashing algorithm and the exact same code. So if I were to pass code through a hashing algorithm and someone else, say someone named Steve, were to pass the exact same code, but with one single letter changed through the exact same hashing algorithm, they would get a completely different hash digest. So this is a great way of making sure that a file is not altered in transit or altered before the process is done. And it really identifies very quickly if you're downloading software that was taken in transit and now the hash doesn't match with the hash you were given from the publisher. And now you know, okay, something has changed and I should not trust this software. So once the hash digest is passed through the hashing algorithm, it gets that hash digest back, and then that is passed through a signing algorithm along with the publisher's private key. And this private key and this public private key pair is the one that does the signing, whereas the public key is what users will use to verify that the signing has been done by your publisher, your company's name. Along with using the private key, information about the publisher and the CA is drawn from the code signing certificate and incorporated into that signature as well. So now that we have the original code, the signature, and the code signing certificate all bundled together, the code signing certificate key is added to that bundle, the public key, so that they can authenticate that the publisher saying that this is their code is actually that publisher. And the code is ready for distribution and packaged in a way that the user can verify that the code is signed by your organization and that it's actually your organization giving it out, and that the code has not been manipulated in transit in any way. So as you can see, it's a bit of a complicated process, but code signing is really just a wonderful way of ensuring that the end user feels comfortable using your software and you feel comfortable giving out that software because you've done your checks throughout the process. You know before you sent it out, there's no malware in it. And now you can know that malware is not being put in transit. There's no man-in-the-middle attack occurring where your code is getting changed and now your reputation is at stake. So moving from the actual code signing process, we will touch on why you should implement code signing. And there's a number of different reasons, but here I'll just highlight some of the main ones, some of the what we see as some of the most important ones. And the number one reason is it establishes trust in your application, your software, your organization in general. And this I've touched on a number of times already, but using code signing means that you've gone to the proper certificate authorities, the publicly available ones. They trust you, so that means the customer should trust you. And so since you've gone through this painstaking process of malware scanning, checking code along the software supply chain, and signing your code, you give the end users the security in knowing that you can be trusted, your software can be trusted, and they should continue to use you in the future as well. Now, another reason to use code signing is it opens the door to app stores. So if you're an organization who wants to create applications to be used on big app stores like the iOS App Store, the Google Play Store, things like that, many, and especially the big ones, require you to use code signing before your application can be put on the store. So they want to ensure that they're not putting their name at risk and that you're not trying to put up 20 different apps that all contain malware or spyware and infecting end users. So that's another reason that you should really think about implementing code signing, especially if you work within the app space. Now, additionally, we have the validation of the application author and the integrity of the application. So this goes back to, using code signing, you can trust, the end user can trust your software publisher, they can trust the software itself, and they'll trust the integrity in the future as well. Additionally, code signing is a great way of reducing that risk of identity theft or reputation damage, where an organization, if you don't sign any of your code ever, then people will expect to see unsigned code. And so if anyone comes in and says, I am, company A, and I want you to download this software. And since you don't sign your code, they just trust it because it has your name on it. Well, then they'll download it and it will likely have some malicious code, some malware in it, and it will impact your organization's reputation because someone's stolen your identity. And since you weren't using code signing and they couldn't verify you, then they trusted it and they got infected. And now your name is in trouble because someone else used your name. Now, one final reason for implementing code signing is it provides a great way of detecting malicious alteration of legitimate code. And this is going back to, using that hashing algorithm, hashing your code. It creates that cryptographically unique hash digest. And so because it will be that fixed hash digest, unless a single letter or more is changed, then the end user will compare that hash that they've gotten in the one that has been sent to them, and they'll compare it with the one you've sent, and they'll see, oh, it's different. The code has been altered in transit, and they'll let you know, and now you can handle that process in between. But this is just a wonderful way of making sure that no malicious alteration occurs in the process. And one other thing I'll bring up as well for the reasons for implementing code signing is if you see the image in the bottom right here of the user account control, I'm sure many of you have seen this before when downloading any software or things like that, firmware updates, where you get this window that pops up. And if you look at the one on the left with the yellow banner, you'll see that it says, do you want to allow the following program from an unknown publisher to make changes to this computer? And if you drop the show details tab there, you'll see that it says, we do not recognize this publisher. It's not someone known. The code is not signed, is really what it's saying. And so we can't verify that this is safe to use. Whereas if you look on the right side, this bootstrapper, the setup bootstrapper, was signed by the Microsoft Corporation through code signing. And so you see right away, this is a trusted organization. It's been verified that it is the Microsoft Corporation. And so you'll feel a lot more comfortable downloading and using that software. So this is one of the big things that code signing does, is they can verify the publisher, your operating system, by just seeing that it's been signed and that it's been signed by your organization. So that covers the biggest reasons for implementing code signing. Now we'll take a look at some of the challenges and threats you might face when code signing or before code signing. So one of the biggest issues we see as consultants is the improper storage of keys. And I don't mean just having keys in a plain text file. That is definitely an issue, but I even refer to things like software-based key storage, where your private keys are stored in a software version of a storage location. And it's much easier to take things out of a software-based storage system than it is a hardware-based storage system. And here I'm referring to something called a hardware security module. And these are large devices that are usually racked in a data center. And these devices will store your private keys very securely. And really the only way to steal the keys from these HSMs is to go into the data center, take the entire hardware security module, hope that the tamper evidence of it does not go off and lock the HSM, and then somehow break the algorithms within that HSM to steal the keys. So it's a very, it makes it much, much, much harder to steal keys if you're using the hardware-based version. Now, additionally, we do see a lot of little to no audit trail or visibility into signing operations. And that's a huge issue, especially if an attack has occurred and you have sent out malware, or you find in the process, say you're scanning in the third phase of the software development lifecycle, and you see that, oh, there's malware in this. Well, now we need to trace back and find out where this came in. Was it someone outside of the organization, or was it an insider threat? And since you don't have that visibility into the signing operations, you can't track where that came from. And it just becomes a big thing of, well, now we don't know where it came from, and we need to lock down our supply chain, but we don't know where to do that at. So that's why we really recommend having a lot of visibility into signing operations, as well as in the development, software development lifecycle as well. Now, a couple of other issues we see are signing events not being centrally recorded and little to no approval required for signing operations. And this goes back to having visibility into your signing operations. If your signing events are centrally recorded and you have a number, say you have a number of developers across the world, as most organizations do. Well, if the signing events are specific to each location in the world and you don't have them all located in one central location, then going back and doing that crypto forensics on an attempt to put malicious code into your code cannot be traced as easily without having that centrally recorded signing events. Now, going back to this little to no approval for executing signing operations, if you don't have things like workflow management within your organization, and especially within your code signing process, anyone could come in, request that the code that they've completed be signed. No one will look at it. And because there's no approval in place, that code could get through with malware in it and infect all of your users, hurting your company's name and hurting your company's security reputation because you weren't checking that they were allowed to sign that the code is safe to give out to users. Now, one last thing we'll discuss about problems that you may face with signing code is the limited visibility when having a number of different developers. And this goes back to that global distribution of development teams, where you don't have the controls in place to ensure that every member of the team, every location of the team is following all the correct rules. And you also don't have as much visibility because you're not centralizing your logs, you're not, collating everything together. It's all spread out. Everyone's following their own rules in the different development teams. And so that creates a lot of issue with visibility into the process, as well as exposing yourself by having such a spread out team. So that's why we recommend things like central logging and just ensuring that there is no ad hoc processes, more of a built process that has been tested, a CI/CD pipeline, things like that, where there is a specific process in place that all developers must follow within your organization. Now, taking a look at some of the other threats and risks, and a number of these I have touched on already, but they're just so important. I think it's very important to go over them again, starting again with that improper storage of crypto material. Improperly storing your private keys, in this case, what I'm referring to is software-based storage of keys. It makes them more vulnerable to compromise. And as you'll see in our next slides with the different attacks, that's how a number of different attacks occur in the software supply chain. You have an improperly stored private key that has your organization's name on it. It's a software storage based, or even in a plain text file at the worst. And someone can come in, your systems are weak, someone comes in, steals the private key, gets a code signing certificate in your organization's name, sends out a firmware update from your organization, and it is then downloaded by all your users, and your name is now hurt a lot, and those users are hurt as well. And so they may never come to trust your organization again after something like this. So that's why we recommend in your code signing process, as well as just in your general storage of crypto material, using things like hardware security modules, hardware-based security, so that you can follow that best practice. And often it's mandated that you store keys using hardware security modules. Now, touching on forged updates, this is in regards to malicious software or firmware updates getting improperly trusted, because yes, your operating system can detect that software is signed. It cannot, however, detect if there is illegitimate, or I should say infected software being downloaded. So you really need to focus on using things like malware and virus scanning in your software development lifecycle, because as long as you're checking all along the way and you're using code signing so that a man-in-the-middle attack doesn't occur, you should never have this issue, because you'll be checking the code all throughout the process. You'll be ensuring someone within or outside of the organization is not infecting your updates, and you'll always be certain that your code is getting to the user without being infected in the process. And if that were to happen, they would let you know immediately, and you could remediate that quickly without having anyone on the end user side infected. Now, one other thing, and I brought this up in the last slide as well, is ad hoc processes. And this is referring to a lack of a process in place for having your teams, your different development teams across the globe working in the exact same type of process. You might have one team that's following the rules to the letter, and another team that is doing it, however they wish, with, say, no virus scanning, but they are doing approvals, things like that. So you want to make sure you have a very well-defined process. That workflow management is very vital in this, and just ensure that you have things like centralized logging so that you can perform different security forensics if a compromised update does go out or things like that occur, so that you can have this process to follow. Everyone is following it, and if they miss a step in the process, you'll know immediately, you'll know where the issue lies, and you can go back and fix that. So now we will discuss a few of the recent code signing attacks. Specifically, Kaseya VSA is the one we will touch on today. And throughout the past 10 years or so, there have been a number of different supply chain code signing related attacks, things that having proper security measures in place could have stopped. There was the ASIS attack, there was the D-Link attack, and the second D-Link attack, and more recently, the Kaseya VSA attack. So going into just a high-level view of kind of what happened, how the attack happened, is the Kaseya VSA software was in the attack used to distribute malware to different endpoints. And the way this software works is the software provisions agents at every endpoint it's installed on. So every single end user using the Kaseya VSA software would have an agent put at their endpoint. And these agents have the ability to do things, certain administrator privileges, such as changing files or adding files or writing files into directories. And this is kind of the core of where this started. The endpoints were attacked, and all these endpoints ended up distributing malware with a legitimate certificate from the organization giving out Kaseya VSA. Now, getting into a little bit more detail on this, the way this attack worked was these infected agents had the malware first write a file into the endpoint's working directory, and then run a PowerShell script to turn off all antivirus systems. So immediately, the end user system could not detect that there was anything wrong because nothing wrong had been done yet. And then once those antivirus systems were off, the malware would turn that file into an executable and run it. And that executable to be run would need to have the file itself actually be signed by a legitimate certificate. And so what these attackers did was they managed to get a hold of a rogue, we call them a rogue code signing certificate, but basically they stole the private key from a company associated with this organization because it was improperly stored. They created a code signing certificate in that company's name, and then they distributed these updates to the agents that ran this malware, and the malware would run through the systems and spread, and it was a huge issue. It has been hurting it wastes the time of the organization, it wastes the money, and more importantly, wastes the reputation of the organization. They just, many people might not go back and trust that organization after an attack as big as this. Now, some things that could have stopped it are actually things we've talked about through this entire process. Proper management and transparency into code signing operations could have saved hundreds of users from being infected with ransomware. If they'd had things like approvals in place where someone had to get approval before the code was signed and pushed through the process to be given to end users, someone would have noticed, oh, why is this? Because the company that had the legitimate certificate was a taxi company with the organization. So it's something like, why would this company be signing this code? It doesn't add up. But since it was lack of or minor approvals in place, then they didn't check as hard and they just saw a legitimate code signing certificate, it can sign and go through. One other thing which I've harped on this entire time is the storage of the private keys. Since this organization's private key was stolen, the key was stored improperly in software-based storage, and it just caused so many issues that could have been stopped as simply as storing that key properly. This malware would have never been able to run on an end user system if they'd stored their private keys properly. So this is the reason, as you can see, as well as these other attacks that have occurred, that we think it's so vital to use things like code signing and proper code signing as well to secure your software supply chain. Now, one last thing I'd touch on is some different best practices for securing the software supply chain. And these are, like I said, things I've talked about this entire time, but I think it's important to reiterate these at the end here. And that's centralized logging of any code changes that are done so that you have think of the word right now, but basically someone is in charge of the change to their code. So they're liable for any changes done to that code that were malicious. Additionally, we have malware or virus scanning throughout the process. This is one of the most important parts because as long as you're checking at each part of the software development lifecycle, you can ensure that there's no malware going out directly from your organization. We also have securing our private keys with HSMs, and that's, like I've mentioned so many times, so important. Having those private keys securely securely managed is just vital to this process in every single way. And one last best practice is integrating into your CI/CD pipeline. So ensuring that you have some type of pipeline, some type of workflow management in place where code signing is done at some point in the process, specifically the end usually, and it is always there. No matter what software you're putting out in or outside of the organization, you're ensuring that you are checking that code is being signed if it's allowed to be signed and if it's approved. So that is our best practices, and that is the end of my presentation for today. Tanisha, I'll turn it back over to you for any questions there are.
Thank you so much, Riley. That was so informative, and you really highlighted a lot of the importance around code signing and how it protects us in the long run, right? So it's one of those tasks you got to implement in order to protect your company, protect your reputation, and so forth. So we do thank you for sharing that with us. And as mentioned earlier, if you have any questions, please type them in the Q&A box at the bottom of your screen there, and we'll definitely have them answered. I do see a few questions, so we'll kind of get right into it though. And the first one is, where and when do you recommend code signing? Similarly, where and when do you recommend verifying the signed artifact?
Absolutely. So this is a great question, friend. We recommend that you do code signing. The code should be signed at the end of the process. The actual signing of the code should be at the very end, right before it goes out to the end user. But the actual code signing process, the platform of scanning your code and things like that should be done at all points in the cycle. So the final signing is right before it's sent to the end user, but the actual process involved with malware scanning, approvals, things like that should be all throughout the process. And similarly, like you said, the verifying the signed artifact, that will be done on the end user side, and that will be done because of your signing of the software. They can verify with the public CA using the public key you've provided, and the end user is verifying that signed artifact at their end.
That's great. Thank you so much for answering that question, and I hope it answers the question to the person who asked. I'm going to move on to the next question for you, Riley. And what we have here is, how can organizations ensure that their code signing practices are compliant with industry standards and regulations?
So there are a number of different ways to do this. The biggest way I would recommend is using an organization like Encryption Consulting. We'll go through your processes. We'll ensure that you are following all the standards and regulations. And additionally, the National Institute of Security Technology, the NIST, puts out a number of different regulations, recommendations, things like that. And if you follow their guidelines very specifically, you should have no issue staying compliant with the different regulations and things like that come out.
That's actually important to know. And thank you for sharing that. And one of the last questions I'm seeing here is that you mentioned a number of risks and threats to code signing. Is it still safe to use even though there are so many risks involved?
Yes, of course. I do understand, because I did touch on a number of threats and risks, but that's why we recommend things like code signing platforms, where it's all in one as opposed to just the signing of the code. Where these code signing platforms, we have something called Code Sign Secure, which is our code signing platform, and we integrate into the process with your CI/CD pipeline. There's malware scanning, there's HSMs involved. So not only does it handle the signing of the code, it handles everything before, in between, and after as well.
I'm not seeing any more questions in the chat box right now, but I know that I guess we can kind of wrap up here. But before we do close, I just want to let everyone know, if you have any more questions, you go back to your desk after this, you're like, oh my gosh, I have a question. Please feel free to reach out to Riley and let him know what your questions are, and Riley, I don't know, just drop your email maybe in the chat box there, so that people can reach out to if they have any questions. And let me know. And for those of you in the audience, if you have, just general questions, you want to kind of do a, you know, go ask our company, ask the people that work with us, and get a demo of anything, let us know. We're definitely here to support you on that. Riley, I do want to thank you so much for joining us today. It was very informative and super helpful. So many things going on. It's really important that we protect our business. For those of you in the audience, please keep an eye out for an email. We're going to have this replay sent to you in the next day or so, and it'll have a link to the replay, but also you have an opportunity to join our online community where you can continue this discussion. If you have any questions, you can also ask them directly in that community group that we have. And also look forward to us on July 11th, actually, where we're going to have a kickoff and host a chat once a month where, hot topics and all that. Our next webinar is going to be on July the 19th, which is on migration, which is an exciting topic.